Help us around today. We have 3 stops. The first one is a conventional water treatment plant in Elverum vannverk. We will arrive there shortly, I think in 5-10 minutes. And then there are 2 more stops. All of them, by coincidence, is by the Ganges of Norway, the biggest river we have, Glomma. So we'll be following this from, we're quite close to where it goes into the ocean now. We follow it up inland. So our second stop will be in Elverum. It's a water treatment plant that treats groundwater with a very special redox method, which you'll learn more about. And then the last stop is some pond system for sanitation treatment, which is also very interesting up in Rena. I think that is about it.
Can everybody see the screen? Okay, welcome to Elverum vannverk. I'm going to briefly just go through a little bit of information about the company and then go through the process. It will be fairly quick because you don't have much time. We only have 1 hour to go through this and to take a walk inside the treatment plant. My name is Lena. I've been working here for about 5 years now. Started out as a trainee. I have a master in chemical engineering and biotechnology from NTNU, the university in Trondheim. So I have a bit different background than you do, but that doesn't matter. We need all kinds of different competence in this area. NRV and NRA actually share administration. And that's located down in Lillestrøm. That's where I have my office, because I work for both companies as a project manager and engineer. And so we have our own lab, accredited lab, that serves both companies and also private customers. We have the drinking water treatment plant up here. Those people are stationed up here all the time. And the wastewater treatment plant. We also have a maintenance department, also electricians and information technology workers, and the administration, and a manager who works for both companies as well. So that's just very briefly about the companies. There's more information on our websites, but in Norwegian. But I'm sure you're getting used to using Google Translate. Should work, more or less. So we are an intermunicipal company. We serve 6 municipalities in the area. I'll get back to which 6 those are. We give treated drinking water to roughly 140,000 inhabitants. We also provide the municipalities provide the further distribution of the water. We only have the main pipe system, which I'll show you on the map. We roughly produce 16 million cubics per year, roughly 1,800-1,900 cubics per hour, or 500-600 liters per second. So we are fairly large on the Norwegian scale, but not the largest. I think Oslo is certainly larger. And the plant needs to run 24/7. So in addition to a process control system, we have a guard down at the administration building who is looking at the screens when we're not at work. So after 3:30, between 3:30 and 7:30 in the morning. So this is the main distribution system. So our owners are Lørenskog, Rælingen, Skedsmo, Nittedal, Sørum, and Fet. So we are located up here. Take the water from Glomma. We serve Sørum over this line and up here, and the rest of the 5 municipalities through these main lines. Also have, I don't know what it's called in English exactly, but this is like elevated pools. Could that be, extra magazines along the distribution system to have some extra reserve in case something happens. We also have these old treatment plants that we can operate if we have a leakage here, for example, or here, and we can start these up and distribute water from these old plants. But they only have filtration and chlorination, so it's not a good enough purification for today's standard, because you will get water with color, and we don't have two hygienic barriers on these treatment plants. So we're working on connecting us to Oslo over Lørenskog and Nittedal. Also in the east to another treatment plant in Aurskog-Høland, and hopefully in the future to the north to Ullensaker and Eidsvoll maybe. They are planning a new treatment plant up here somewhere. Because if something happens to this treatment plant today, we don't have enough reserve to our 140,000 inhabitants. So it's really a big crisis if something were to happen here, but we have duplicated production lines and everything, so it's fairly improbable that something should set our production out of water totally. So yeah, 110 kilometers of main pipes, and we have these basins to regulate the distribution and to also have in reserve in case we have a leakage or breakage of the main pipes, and 11 pump stations. And we also deliver water to Coca-Cola, Ringnes, who produces beer and sodas, and Arcus, who are mainly producing spirits, I think, aquavit and stuff. Yeah. So this is what the drinking water treatment plant looks like. When we go inside, we'll follow the water through. Here the raw water comes in, we add chemicals. This is a sedimentation unit. Then we have, as you can see, we have two lines of everything, two sedimentation units, two filter holes. This is coal filter downstream. The UV is located here, and pure water basins are these two. I'll get back to those. So our raw water source is Glomma. The longest river in Norway, has a downfall area the size of Denmark. So the good thing about this source is that it will never run out of water. We take out around 1,000 part of the total water flow, so that's the good thing about it. But of course, it has upstream wastewater treatment plants, industry, agriculture. So we need to have a really good process here, of course, because the raw water source is contaminated with different stuff. But having a large water flow also makes that if something were to be let out in the river, we also have this enormous dilution. So that's also an advantage with this large river. So we take the raw water out just north of Sørumsand. We have 3-kilometer pipe in the river, and then we pump it up roughly 110 meters, and then it flows by gravity in a tunnel into the treatment plant. And you'll see this pipe when we go in. You don't get to see the actual raw water, but you'll see the pipe coming in. And the chemical purification is the first step. I'm sure you know all about this maybe at this stage in your studies. But yeah, you know the basic principle. The particles in the water are mainly negatively charged. You add a positive polymer and you get this flocculation. And we use polyaluminium chloride. In addition, micronized marble or calcium carbonate, and an organic polymer to strengthen the flux in the end. And this process is dependent on many variables, so we are very careful with this step because it's definitely the most important thing that happens in a drinking water treatment plant. Because if your chemical purification step don't work, then you can have all the UV and chlorine you want. I mean, you'll get problems downstream in the process. So after we've added the chemicals, the water goes into a vacuum tower, where there's a pump that for some seconds just pulls the air out and gets the water to rise. and then lets the air back in to get it to fall. And that just makes the water, when it comes in through the pipes in the bottom of the basins, it has a sort of slow pulsating movement. And what that does is that the sludge that will sediment will stay afloat just above the bottom and actually act as a sort of filter. So we sort of filtrate the water with the sludge. I think we are the only drinking water treatment plant in Norway that has this configuration. I'm not sure why, but it works really well. We remove a lot of particles in this step. And there are no movable parts, so very little maintenance on this equipment. So the water comes in, it goes through the sludge that's already there and gets sort of filtrated, and the particles that are let through will hopefully sediment on the lamels above. And when the sludge carpet, that we call it, when it gets, it will of course increase in size. The sludge will go over an edge and we'll just send that to the sludge treatment. And with the sludge, we just let it sediment some more, remove some more water, and then just let it into the wastewater pipes. So it just goes down to the wastewater treatment plant. And then we take the water out on top. And when you get inside, you'll see that the water we take out here is fairly clean. So we, as I said, we remove a lot of particles in this step alone. But not all, so we need a really good filter also. So the next step is a 2-media filter with a Leca product, filter light on top and sand on the bottom, different layers. And to remove the smaller flux and particles. And we back flush it with air. We just send air through the bottom when we have to flush it to get all the flux and particles up in solution again, and then just back flush with water afterwards. So it's a downstream filter, but we back flush with air and water the other way to clean the filter. And the next step is the carbon filter. Because we have Glomma, it could contain organic material that may cause smell or taste, or it could be environmental toxins. So this carbon filter are supposed to absorb organic material. So that's our next step, sort of a polish of the water just before disinfection. And we change the coal every 4 years. So it's fairly durable as well. So just fairly new to the plant is the UV disinfection. We got this into operation last December. So this is effective against parasite, bacteria, most viruses. And the principle is these incoming UV rays destroy the DNA of the microorganisms and make them unable to reproduce. And when they are unable to reproduce, they are also unable to make us sick. So, yeah, and the same principle that if you stay out in the sun too long, you may get skin cancer. It's the same thing, because the UV damages the DNA. But we have actually kept the chlorination as well, just to be sure. Also because if something were to happen with the electricity to the UVs, they very easily fall out if there's a lack of or something wrong with the electricity flow. So we will take around 15 minutes to warm them and get them back into operation. So just to be sure we can deliver hydrogenized water at all times, we've kept the chlorination, so it goes all the time, even though we might not need it, really, because we have, with the UV, we have two hygienic barriers. We have the chemical purification with filtration and the UV. So we actually have three, you can say, except for parasite, of course, because to kill off the parasites, you need so much chlorine, the water would taste really bad. So, but we stay on this the requirement from the drinking water law, or what I should call it. So we try to stay on 0.05 milligrams per liter after 30 minutes, even though we have the UV, just to be sure. So yeah, this was the treatment plant. When we go inside, we'll follow the water from the tunnel. We'll see the pipe coming in. You won't actually see the addition of chemicals because that happens below the floor here. But we can go and look at the sedimentation unit, the superpulsator, and we can go along the filter lines, briefly look at the UV, and then we should go back out. And just, yeah, maybe we should take a question round now because it could get a little bit noisy inside. And well, if you have any questions, just fire away. If not, we have to go in about 5 minutes. Yeah?
Does the water flow by gravity through the entire plant?
Yeah, we don't have to pump anywhere, actually. But we have to pump it up from Glomma, and that's a huge expense. We have some enormous pumps down here to lift all that water 110, 100, 120 meters. So that's a big yearly cost for the treatment plants. Yeah?
What is the reason why you have the UV first and then the chlorination? Could it have been...
Good question. Lies in the chemistry. If you were to add the chlorine first, the UV rays would destroy the active component, and you wouldn't get an effect from the chlorine. Yeah. That's also why you need as pure water you can have before these steps, because particles you can have a shadowing effect, and then you can get microorganisms sort of hiding in the shadows from the particles. And sort of the same thing applies for chlorination. Organic material will absorb the chlorine so that there are less chlorine molecules to react with the bacteria or the viruses. So you need to have really pure water going into this step. And of course, yeah, add chlorine after UV. And also we add sodium hydroxide in the very end to raise the pH. And we also do that after chlorination because the chlorine works better at a low pH. So we raise the pH afterwards. So yeah, there's some chemistry involved. Yeah.
How long is the water in the plant from it comes into?
Yeah. That's a question we get often but never can really answer. It depends on the production, of course. But we think it's around 8-10 hours, something like that. But it also depends which pure water basin it goes through, because this old one is 3,500 cubics, but then we built a new one with 17,000 cubics. So that it will take longer time going through this way than that way. But yeah, it takes some hours. It's a fairly quiet process. It takes this unit. You have to have a slow water rate because it needs time to settle. And the same thing applies for the filters. If you run it too fast, the filter will clog too fast, and you get problems. So yeah, there are more time-efficient technologies today, but this was built in the 70s, so it still works. Yeah?
Did you see there is filtration going on at the superpulsator station?
Sorry?
Do we have filtration going on, or is it just natural sedimentation?
Yeah, it will sediment on the lamels, but then when the water comes in the bottom, it will sort of get filtrated through the sludge that is already there. So the sludge sort of acts like a filter, but it's not an actual filter. The actual filter is downstream. Yeah. Okay. Want to see the treatment plant? So behind here we have the tunnel. where we bring in the raw water. So this is just a pipe leading the raw water into the treatment plants. The blue thing is a valve where we can regulate how much raw water we take in. And if you see that the pipe is a bit narrower behind the shelf there, that's a flow measure. So that tells us how much water we're taking in all the time. So the addition of the chemicals rely on that flow measure to get the right concentration. Yeah. So this is our navel cord actually. Yeah. This is our pilot plant. If we want to test new chemicals or new filter material, we can use that thing. So the blue square one is the super pulsator. The two blue things in front here are two filters, and the cold filters below. So we've actually used this several times to test new material, to be able to test it without adding it to the full-scale plant first. That's really helpful.
Is that sort of control? Control?
Yeah, it's just a downscale version of the whole plant, so you can test different things. Yeah, it has the same process control as the main plant. Also, like I said, 2 lines, and you can also take out samples throughout this filter to see where does the clogging start, and you can study different effects using this. It's very helpful. And so this is the sedimentation pools. On this side we have these honeycomb sort of shaped lamels. On the other side we have just ordinary lamels. And in the center there is where the water comes in. And then you can see the water with chemicals added. And the water you see on top here is going from here to the filtration. We'll just go through. Been back flushed. So now you see the water going, I think it's filling back up. Yeah. That's just been flushed. The other one is an ordinary operation. So the water you see coming in here on top is the same water you saw on top of the pools in the other hall. Because there it comes out on top and goes in on top on these filters. And then it goes down through and down to the cold filter. This is the cold filter.
Okay. And what is that 3.9 in something?
That's the pressure.
Okay.
Pressure difference.
Pressure difference in...
Yeah, so if that pressure increases, that tells us we have to flush the filter.
the pressure depends on the chamber, or I mean...
It measures the difference between the pressure on top and on the bottom.
I mean, there's the same pressure of bottom and top in the whole chamber, or it's depends?
No, it will be different because in the bottom you have water pressuring, more water pressuring down. But if that pressure increases, that tells us there's something wrong with the filter, because the water won't go as easily
So
through.
it must need to be almost constant over different chambers?
Yeah, in this filter especially, because it shouldn't clog.
Yeah.
It should just absorb dissolved organic material. There shouldn't be any particles left. Yeah. The pool you see in front is the small pure water basin, and then the water that you see had just been added chlorine and has been through the UV in the corner here. But we'll go and look at that. But we have a larger one also. We can take a look at that on the way out. These are the UV aggregates. We have 4 of them. We need 3 to treat the maximum production. And then we have 1 in reserve. And you can see which 2 are in operation because they have a green light on them. Fully equipped with a flow measurer. And you can see the UV transmission on those screens. And we chose these medium pressure aggregates. You can choose between medium pressure and low pressure. The low pressure aggregates are much larger and have many more lamps. So they take up a lot more space, and space was sort of important to us being inside the mountain and everything. So these were the most convenient. And it also makes changing of lamps much easier when you have fewer, of course. It also has an automatic cleaning system. We have to clean the quartz coating of the lamps because you will get some minerals making a layer on the lamps. So inside there's a sort of a thing going around the lamps back and forth that contain an acid solution cleaning away this usually I think carbonate based layer that forms. As to keep the transmission as good as possible, to keep all the light from the lamps actually treating the water and not being captured on the way out. So the lamps are in this direction and just treats the water flowing by in this direction. So the water comes in that end from the coal filter, and then it's distributed to either that pure water basin or the new one inside the mountain hall, parallel to this road. We'll go look at that, because that's bigger than the other and more fun to look at. So yeah, that's the UV. Before we go down to the pure water basin, I have to tell you, please be very careful not to drop anything into this water, because this is actual purified drinking water going out to the consumer, so it's very important that it's clean. So yeah, just be a bit careful with the helmets and everything. We had white tiles, and you always get some remnants from the coal filter that makes sort of a brown blackish layer along the surface of the water. But since these walls are dark gray, I don't think we'll ever see it or have to do it. But we can. I mean, if you see that there's a wall in the middle,
you can
so we can separate. Yeah, we can still produce from one end and do some work on the other. So. That's why we have that wall. But sorry.
For how many people this water at a time they are serving from here?
How many people we are serving from here?
Yeah, at once. I mean, at a time.
Almost the whole region. I mean, we have that other one that produces as well. I think it's half and half.
Yeah.
So 70,000. But it was made that big to have a reserve in case something happens. And we have some hours in reserve here.
And we have other reserve beyond this?
Yeah, out on the distribution net we have some smaller basins with some thousand cubics just in case. But not this big.
Yeah, I see.
But Oslo is actually going to build, I heard, 2 large new basins now. This is 17,000. They are going to have 2 with 100,000. So they are a bit bigger than us. Yeah.
Doesn't matter, it's all in Norway.
Yeah.
Velkommen til Elverum vannverk. Det er et av de vannverkene i Norge som har, eneste i Norge som har Uridox 2-metoden, med ferdig jern og mangan. Og så litt reklame, så er vi nummer 2 i smakstest. Og så er vi nummer 4 av 69 kommuner som er da på landsbasis det beste vannet i Norge.
Oh, yeah, two questions. You just welcome you to this Elverum water treatment plant, maybe? Yeah. It is the only one in Norway that uses this technique. It's called vannverk. I wouldn't know how to pronounce it. Vannverk. Vannverk method. It's a Swedish method, and then he's also making some commercial because this is it's won a prize. It's been the best taste of water in Norway, of the water treatment plant. It's number 2. And there's hva var den andre? At det også var altså kvalitet, var det ikke det?
Kvalitet og sikkerhet, lekkasjer generelt da.
Så var det helt i toppen, var det ikke det?
Ja, det er jo over 4 år kan du si, den målingen er godt. Altså vi har og da vannprøver da, som vi må levere hver mandag.
Yeah. Is water samples being taken and because of some quality and like a safety of always delivering water and not having any lack of it? They're on top in Norway. It's the measurements going on for 4 years.
Ikke så har jeg lagt ut laget noe slikke. Det er da prinsippskisse over Uridox-metoden. Og så er det da, den ligger på nettet. Det er reklame, en liten røring der. Litt forskjellig, så vil jeg skrive i bok, bare signe navnet, og så kan jeg ta med i vannflaske som jeg har laget stein. Så vi fyller opp den bort i brønn 2. En mener det heter på. Med råvatten, og det er da helt ubehandlet vatten. Det kommer rett ifra kilden. Det kan være litt luft i det vattnet, på grunn til den Uridox-prosessen. Men det er da ubehandlet vatten, det er ingen kjemikalier, det er rent.
He's going to hand you out some drawings, like technical drawings of the thing, so you can understand it. And there's also this commercial with a picture you saw. And then there's the last one is a folder you have there also. You can also find on the internet. And also there they have a guest book he wants you to sign, just as you come along. And he'll give you a water bottle from this place. And then we'll go and fill it ourselves in with the water coming out. And it's just no chemicals added or anything. It's a natural process to use there, just with aeration. Gives the iron out, and he'll tell more about that later. Yeah, there might be some air in the water, so it might look a bit like a lot of bubbles, grayish, cloudy, but it's clean. Var det
Ja, nei, det er mye som prater der. Det er da forholdsvis lite vannverk. Vi leverer ca. 6000 kubikk i døgnet, og kan levere 15 000 kubikk. Så vi leverer vatten til 15 000 personer, cirka.
Yeah, so they make 6,000 cubic meters, cubic meters of water every day then. But they can make up to 15 cubic meters of water, and they're supplying 15,000 people now. Yeah. 15,000, yeah. So it's quite a small plant.
Så da kan vi kanskje gå bort på brønnen igjen, etter at man har forsynt seg med slikt og vannflaske. Og så signert navnet, eller gjerne noen kan skrive noen få ord om fra hvor dere er, liksom. Ordet eventuelt var liksom litt viktig.
Yeah, in the book you also say where you're from or something, and we'll grab the bottles and go to well 1 and then well 2 later. Vann er tingen rett fra springen. Yeah, it's good. Grab the papers. The only thing they do to the water is adding air or oxygen, and then some lut. Natrium hypochlorite. Yeah. Basic. To raise the pH. To raise the pH. wells into the small house where it's enriched with oxygen, and the oxygen added and the enriched water is then pumped down again to the groundwater. And the reason is down in the groundwater zone, it starts like 5 meters under ground level, and the bacteria will oxidize the iron and also the manganese, but mainly iron, and then it will become insoluble and precipitate out, and then the groundwater aquifer itself, the porous media, the sand, will then filter the iron and manganese away, so the water will be clean when it is pumped up from the groundwater from here. Then they pump it down again because of the microbiology, the bacteria and the oxygen. They will clean the groundwater enough, and then they pump it up again. It's just
Going to the groundwater.
yeah, this going down again to the groundwater, 26 meters below us. And then it's like they change the process all the time. Like now this well is running in the other one, and then I think it's after 4 hours it's been down there. Then they pump it. He will tell more of the details.
Is this pumped to the houses from the groundwater?
No, it's another well they pump it up from again. But I think it's inside here again. It's like an interchanging process. Yeah. Manganese, that's all. And then it's a UV light connected there to the pump who pumps it out of the groundwater that removes the. No, you don't use it at all?
Never.
Oh, you have it just for emergency purposes?
Only just government and Mattilsynet said we must have UV.
Must have it, okay, yeah. Cool.
We never use it.
Great.
So how do you use? How do you take away the ions?
The iron?
Yeah, the iron and the magnesium.
Where I put it down.
It participates underground.
Going back.
It's precipitation.
It's a natural
Going back to
process.
ground.
Yeah, with the bacteria.
I think they are using it to clean it. It's not that they are...
No. No, it's the removal of the iron and the magnesium from the water.
Yeah.
But how do they do it? Is it precipitation?
Because it goes from divalent to trivalent, so then it's not soluble in water, and then it will participate out. It's like the chemistry of it. Because when it's
it's a chemical process.
if it's Fe2+, it's solved in the water, but then because of the oxidation, it becomes trivalent, like Fe3+, and then it participates out in the ground. Yeah, in the ground. But it doesn't really clog the material because it will take like 750 years or something, the article says. It looks like the pumping is finished now, right?
They stopped it.
Yeah, they stopped it.
They changed the well.
Yeah. Which well is it now? Do you know? Okay. Just automatically or you just change it? Okay. Er det sand vi gjør det? Ja, litt grann. Ja,
Kommer i litt sånn, gjør det.
ja. From between 9 and 11 meters below ground, and then it pumped up in here, just aerated in 3 tanks. And what you saw, the little sand at the bottom, is like all the sand that's been accumulating since 1997. Oh, wow. Yeah. And then the water comes out in.
And the next step is here.
This is basically pH adjustment. They're raising the pH the same way as the other place with lut. And vad heter det på engelska? Natrium. We say that? Yeah, potassium hydroxide. Sometimes there's an air pump here as well, or else there's some aeration going on here on a small step underneath. So after water's been here, it goes through the extra aeration and then to the clean water tanks.
And normally we use disinfection stuff here. We have this, but we have never used it so far.
So this is chloride?
Yeah,
Yeah. Never?
never. It's not necessary.
Yeah, that's great.
How do they take care of the turbine?
Nei, det er så rent. Så det.
It's very clean groundwater itself, so it's no problem. There's no turbidity to take care of.
Okay?
So then the clean water tank is this one?
No, dette bare en luftetank på grunn av nå skal vi svinge opp.
We probably won't make it to the other water treatment plant, but we have the samples of the membrane filters here. You probably already had the lecture with Aqua and knows a bit about this because it's super compact, like it's 1 square meter or something the other place, so it's not much to look at. We'll just pass them around. The one who's thicker is 5 micrometers. No, yeah. And then the other one is 10. So yeah, just for you to see. Here you go.
It looks like
Det er Rena vannverket. Nå er vi på renseanlegget. Her er det fint å snu rundt her oppe. Ja, så du kan bare snu her borte.
How many log can they remove with this one?
I'm not sure. You could remove all bacteria almost, but the problem is you can't remove virus.
Yeah, no.
I should probably say more information, but I just don't have all the information. Then about it's 4 ponds, 4
Ja,
damer,
ja, ja.
and they're all the capacity is like 3,000 cubic.
3000 kvadratmeter.
And each,
Square meter.
Yeah, each pond is 3,000 square meters.
Mm.
And then the depth of each pond should never be more than 1.5 meter because you want aerob condition. If it's anaerobic, you don't get the correct process. So when it's more than 1.2
meter.
meters,
Yeah.
you stop the loading and
Yeah, we stopped and changed to another.
another pond.
Yeah,
So it's usually you scrape 2 ponds a year, was it that?
1 time a year.
1 time a year.
Yeah, we stopped water into the. Hva heter det, en dam for noe?
Pond?
Pond, yeah. In April normally, and then we use 2 or 3 months in the summer so the water will be gone, and then we have just a thin layer with slum or sludge, yeah, and we take it with a dig machine.
Yeah, and before it was only a very coarse filtering process going on here. The
Yeah.
grit was
3 millimeter.
3 millimeters, but now they changed it.
Yeah, we changed. We have also the
An extra filter.
so we can saltness filter, so we can go inside and
see.
look at it. But
Yeah.
it smells a little bit bad inside, but
So now there's less sludge because you filter more here.
Yeah, yeah.
What is the reason for that? Because
it's easier to take it away from there,
Here
and
and
we can also use this maybe 2 or 3, maybe 5 years until next time we take away.
shaping, yeah.
Take it away, yeah.
And it's been a landscape architect designing the ponds as well, so it looks very beautiful and it's nice, but there's been some problems with that as well because of all the corners, the hydraulics is not that well to distribute the water and the sludge, so yeah.
So the best is I think a circle with water come up in the center, so we can
Yeah, that's
But-
better.
mm.
Because the water is pumped from like 8 kilometers away or something, is that?
from the whole city.
Yeah.
So we have maybe 10-15 kilometers in pipes before it
Comes here.
comes here. Yeah.
Yeah, but then again the treatment is only the filtering and then the ponds.
And we have also a lot of pumps, so that is also one of the reasons that everything in the wastewater is very small particles.
Particles.
Particles. After visit all these pumps, so the first filter is too big, so we have nothing almost in it. But the next one is much better. So here you can find everything, mice and. Okay, we can go inside. Her ser du det siste trinnet. Her er det en avvanningsprosess.
Okay.
sånn at når filteret er fullt, så blir det rengjort, og så blir det avvannet, så når det kommer i den containeren, så er det tørrstoffinnhold på langt borti 20%, så det er veldig tørt. Det er
Sa du cirka?
20%, tror jeg. Ja, ja. Og tidligere så var det jo TS-en 2%, eller... Ja.
Er det mest fra boliger, eller er det fra industri og sånn også? Bare boliger? Altså militærbasen også, eller?
Yeah, also the military base, yes.
It's scaled for 8,000 person equivalents, this one. And then you say 150 liters per person per day.
Yeah.
And then it comes in here, and then the filter is clean with water, and then the sludge is dewatered here as well. So it's pretty dry when it comes out. There's such stuff, you know. Dry matter content of 20%. Before that, it was like 2%. Yeah. So this, it's the filter.
Where the water comes from here?
From here. We can go here. Yeah. It's come in here. Yeah, this is the first filter. This is a 3 mm filter. And after we go here and up to this filter, and then it go out and outside again, here from here.
He can control this from his phone and via like all the cables.
I can use my Samsung and...
Yeah. With the menu connects his hair with it, yeah. Yeah. With all the modern technology. Yeah, so here he can control all the values. Get the information. 24 hours.
This is prepared for the next season. So we used a dig machine 2 months ago here and clean up the bottom. So now it's so ready. So next spring we open and use this one, and also the next one here.
Some kind of science project research thing where they're cleaning heavy metals with like chopped up tires. It doesn't have all the details. It's been also some with leca and bark, like sawdust kind of, because it binds heavy metals and then the sawdust can take the oil. This is a pond for drying. Yeah, it's just drying the sludge. Not
But now this one has been drained, or this is the amount of water?
No, this is the one drying, yeah.
Okay.
I think the last one is the one we use at the moment.
Okay.
This one has been active for how long?
I think from July.
And so the water passes by itself, or you pump it to the other pond, or how it works?
From here?
Yeah.
No, from the ground here down to the groundwater.
Okay.
We have only sand, and from the bottom here to the groundwater it's about 32 meters. So the water just go past the sand and go to the groundwater and out in the river afterwards.
Oh, okay.
So we have used a lot of testers here, and in the beginning we have sonder, hva heter det for?
Sonder? Sons?
Yeah. Some test equipment in different layers in the bottom of the from here,
like
on 2, 4, 6, 8 and 10 meters down, and after 2 meters the water is clean.
So, the sand filter?
Sand filter, yes, just a sand filter, yeah. Det eneste som vi ser er hvis de tømmer svømmebassenger.
Yeah.
Da får vi klorid, det går rett til grunnvannet. Det går rett igjennom.
Yeah, the only problem we have is that someone is flushing out their swimming pool, then they get chlorine and it goes straight to the groundwater because there's no process for treating that. But the microbiology and filtration takes care of all the the water is clean after 2 meters. Impressive.
Det var sagt.
Because of little rain the last few months, it's not so much water, and also because they filter more of the sludge, the water seeps faster through into the sand. So this pond is not very full at the moment. So yeah, it's very little water as you see. But the fascinating thing, as he pointed out, is it's no smell at all. This is just sewage, and you don't smell anything at all. So yeah, it's very like something is going right, isn't it?
Is it sinking through the mud? Is that the system?
Yeah, no, basically it's like the processes in the sand that, I think there's been a lot of lectures on how that works. Both phosphorus removal with binding to aluminium and stuff, and all the biological processes in the sand itself. The natural process is just doing the job, basically, a lot of microorganisms.
What about the winter time?
No problem.
Even if the water is just high?
No, it's no problem because the water that we pump into this place is maybe 10-15 degrees. So it's always open water here. Yeah.
How do you take care of this during the winter time? Winter when there is a lot of snow.
We don't touch it.
Okay.
We just take a look every week, that's all.
I think in the water inflow, water is so warm. It's because people take hot showers. The water is 10-15 degrees. It's warm.
And it can be. We are in the cold part of Norway, so it can be very cold there in the winter time. I promise you.
But even constructed wetlands function in Norway during winter. So yeah.
The army was a little bit skeptical when we start up with this. We build this at the same time that they come here with this big, the most of the army in Norway, I think, is just over here. And over there is a military airport. And they have a lot of parachutes. And they land around here. So they was afraid that they will land in this water. But so far I think no one has stopped just here. They have control.
But so the problems with the landscape architecture that you say that they were like hydraulic problems to like how the water moves is it?
Yeah, because you can see here you have this. Almost everything we have. The water come in on the other side here. So it's earlier before we start with the filter inside. We saw everything happens in this part, and here we have only water.
Yeah.
Okay.
So that was the problem.
Because the uneven shape is difficult to get the even distribution. Yeah. Circle is better.
So if they do it like this next time, it will be better if they can use one pipe there and also one here, so they can.
Or just a round shape.
Yeah.
Because there's not so many people who's going to look at it
anyway.
Except the parachute jumper.
What do you store the water now? What do you store the water if we don't get water here in other areas?
I'd
store
it here. It seeps to the ground so quickly. It's not standing on top at the moment.
Yeah.
It's so efficient. It's already been sinking down.
Normally we have a lot of rain in this area, but the last 2 months we have almost no rain, so because of that we have no water here.
But so when you remove the sludge, do you change the sand as well, or?
No, not change. we just take maybe 2-3 centimeters of the sand away together with the rest. And then it's okay again.
And I think there will be a time where you will have to like renew
I think
the sand? Or?
Not in my time, I think, because we have tested with the dig machine, and you can see the color of the sand.
Okay.
And after 40 centimeters, you cannot see. You have the same yellow color as normal, but a little bit different, darker color in the top. So I think the whole process is in this layer.
Okay. Good.
What did you say about the getting the wastewater from first point to this place? Is it by sort of gravity or do you pump?
A new pump, yeah.
Smart.
And is it a lot of electricity consuming in like that part of it?
Yeah, we use a lot of electricity. It's necessary here because we live in a valley. So that's a problem, of course, but not in Norway because we have a lot of electricity here.
Yeah.
Okay, shall we go back? So the other one is on this leka, yeah.
From the cars?
Yeah. They have very good tests for heavy. We start up here in 1997, and we have still problems with. I cannot say problems, but cliff.
The Norwegian EPA, like the Environmental Protection Agency.
And fylkesmannen
The guy in the municipality.
They look at this as a normal industry. There's traditional wastewater cleaning, and the test results here is around from 95 to 99.9, so it's almost clean.
It's much better than the conventional plant,
And but they don't accept it actually, so we have a problem there.
They try to close it down almost sometimes. They're actually against it,
What, the council?
The
council tries to close the plant down.
Yeah, maybe, or they not try to close it, but it's like every time they have to renew their permits, there's been like, a hassle.
But how can they argue with science?
It's
Because
I don't think it's safe enough. Maybe it's very strange.
How much can a normal plant remove, like a traditional plant?
Usually it's like between 70. I think the limit is like 70% and 90%. It depends a bit what the recipient, how vulnerable it is. But I think Bekkelaget in Oslo it's been on the borderland even, isn't it?
They struggle to reach 70.
Yeah. And then they have the overflows in addition, and then the leakages.
We're talking 90% and they went...
Like this is 99.9 sometimes. It's ridiculous, right? And this doesn't use any like chemicals or extra energy. Just pumping is the only thing that it all runs by itself, right?
How do you prepare that? Do you go because you see the water seeps down, it filtrates down. So how do you measure that?
You can use tracers and stuff, isn't it? That's what sannsynligvis det har gjort med målinger.
And every month we do a test from this special building over there. We have a pump there in the ground because all the water that comes from here down, we can see the groundwater is not horizontal, but a little peak on the groundwater because the extra water come down here. And we take the test from this peak every month, every 14 days. We make a test, and we send it to the laboratory, and so all the tests we do from there. And that's not true. We have one in the top and one down there. So we have because we have the river in the bottom of the valley here, and the groundwater could come on the 45 degrees to the river. So we have clean water there and if it is not clean anymore, we have this test part a little bit further down there. Yeah. So, but it's very good. The test result is very, very good. Så det kan vi sende over til skolen hvis dere vil.
Ja, det er veldig bra. Ja. Send det til Petter bare, kanskje.
Ja,
det er greit.
ja, jeg har vel ikke e-postmaster, men jeg har telefonen, så kan jeg fikse det.
Ja, det kan du gjøre, ja. Du kan også gi det kanskje greit. He'll send over some results to Petter and then we'll get to you.
Okay.
Any more questions?
Then I lock the doors and we can prepare to go further.
I have one question on the cleaning, the first cleaning plant we were. They clean drinking water. What type of cleaning methods did they use there?
Almost nothing. We the groundwater come into the building, and we just have a pump that blow air into the water. That's all. And the other equipment was just for adjust the pH. Yeah. Yeah.
Just as a small sign of appreciation from Petter, and also you and me.
I think.
For the road.
I think they will loan me in the office for a few minutes now. Thank you very much. Okay, I will lock the doors.
Yeah, then you join us anyway.
Yeah. 5 me, so I don't know what kind of bacteria we can take away, but I think we take a lot of bacteria with 5 me. But virus is hopeless with this one. Er det flere som du har to? Okay.
Yeah, it goes down to groundwater. It's clean before it reaches the groundwater. Yeah. We're gonna because of the process just in the sand.
No, I'm almost finished with my job here, but if there is any one of you that like to do any project with the wastewater or clean water from up here, just take contact and we can try to help you. I will tell you a little bit. I know not much about this, but I can tell you that there we use this, we can produce about 10 cubic meter with water, clean water every hour. And there is only a PLS that control the pressure from the clean on the other side of the filter, and when the difference is too big, it just start to clean the filter, and we use only 2 liters with water for this cleaning process, and it takes 2 seconds, so we don't stop the we have the whole time water for the customers, just, and then we are finished with the cleaning.
And the size of the filter was 1
and the size of the filter is 1 square meter, so it's a very small thing. So, but the teacher will, Petter, yeah, he have more information about this because he contacted the factory last week, so I think he will tell you more about it. Okay, now I am almost at my office again, so bye bye.
Thank you.